Good evening. Thank you for joining us here at NASA's Kennedy Space Center in Florida for this STS-133 status briefing. Joining me is Mike Moses, Chair of the Pre-Launch Mission Management Team.
Good evening.
And Mike Leinbach, Shuttle Launch Director.
Good evening.
We'll hear from them and then take questions. Mr. Moses.
Thanks, Kendra. Let's see, we finished up a mission management team meeting. It was actually a pretty quick meeting in that we didn't try to get into all the technical details. The teams have been working all day long. The problem we've had is a main engine controller showed us a funny signature this morning when we powered up and we're doing a standard check. The main engine controllers are basically dedicated computers that sit on the main engine themselves and control the main engine. So the shuttle main computers tell the main engine controller what it needs to do, and then the main engine controller runs all the pieces and parts on the engine. There's two per engine, a primary and a backup controller. Obviously, we like to have both of them running from a redundancy standpoint. And what happened is today they were doing some power checks on the redundant system, and when they threw the switch to turn it on, it's powered by 3 phases of AC, so an A, B, and a C phase. And that one of the 3 phases didn't immediately come on, and the controller will not work on 2 phases, so it did not come on. So when they were pulling the data to look at that and try to understand what happened, maybe it was a switch or a circuit problem, about an hour and a half later while they were talking and troubleshooting, they looked and noticed that the controller had suddenly come on and that phase B engaged itself and started working. And that's actually not all that uncommon. These circuit breakers are basically single pole push switches, and they build up a little bit of contamination, a little bit of carbonization, and sometimes you have to scrub them by cycling them back and forth mechanically, moving them around to knock some of that loose. Historically, we've seen that in circuit breakers before. So that alone didn't really cause a whole lot of concern, but we did want to talk about the fact that it kind of healed itself after time. But again, that by itself is not all that big of a deal. So they talked a little bit, and the troubleshooting plan they came up with was to cycle that breaker a little bit to try to make sure we've shaken everything off of it, do some actual power-up sequences of that main engine controller, make sure it was healthy, and let it run its own self-checks to show that it was okay. While they were doing that, they noticed a little blip in all 3 phases, it's hard to nail it down because there's the circuit that feeds off the voltage is really feeding us a summation of all 3 phases. So to call it a 5-volt change in the circuit's actually not true. But needless to say, let's keep it in layman's terms. The signature coming out of that circuit showed another little glitch that was a little bit unexpected and we hadn't seen before. The teams struggled with that all day. Struggled's not the right word. They grappled with it all day to try to come up with, is there one cause here? Is there 2 problems? Is it something we understand? Is it in the controller? Is it in the power feed system? Is it the circuit breaker? Is it the switch? Is it the AC system on the vehicle? And in running through all that, they got to a really good story, and I think if we would have had about a 9-hour MMT, we could have heard all that data, judged it all, and been good to fly. But that's not the right thing to do for this team to try to then come in the morning and tank and launch. So it was a pretty easy decision to say that we're getting really close to having really good understanding of the problem, but we need to polish it, we need to organize it, we need to make sure that we're not wrong about it. And in that, we do 2 big things. One is we want to, even though we think we understand the problem, spend a whole lot of time talking about what if we're wrong. So what's going to happen if this controller does flake out, either in the count tomorrow or Thursday now, or once we start going uphill after launch. So what are the consequences? What's our tolerance? What margins does the system have if there's a problem? The other big piece of that is to make sure we're not, to put it bluntly, crafting a solution that matches what we think the problem is and that we're actually having a good physics-based understanding of the phenomenon. Does it make sense that a circuit breaker with a little bit of bad contact could explain both of these signatures we saw? The community feels pretty confident that is the case, but they do need time to polish that story, bring some historical data to show whether we've had instances like this in the past, what was similar to this scenario, what was different from this scenario, what extrapolations we can make, and really spend the time to draw all the dots on the piece of paper and draw the line that takes us from what we like to say, we don't fly with unknown risk, and right now this risk is a little bit still unknown to us. We're going to take another day to get to know it better, for lack of a better word, and make this a known risk that we do understand and we've quantified. You've seen us do that time and time again. It's one of the fundamental tenets of NASA and the Space Shuttle program that we make sure we truly understand the risk we do fly with. You don't want to ever go with unknown risk. And so we're going to take an extra day to do that. Like I said, I think we could have gotten there. I think the data is there in the team, but it's really the better part of valor to let them have the time to go put that story together in a nice, crisp package that we can all walk through tomorrow. So our plan is to let the teams do that. They're going to be working pretty hard overnight and in the morning, and we're going to reconvene tomorrow at 2 p.m. Eastern Time for another MMT. Typically, when we have MMTs, we like to let the teams go off, get their answers, vet that through all the sub-elements, the safety reviews, the independent reviews, the ground ops team, the orbiter teams, the JSC teams, the KSC teams, and come to the MMT with a nice, here's the answer, this is what you should vote on. Makes my job really easy. Tomorrow we'll do it a little different because we're not going to have that chance. We're going to let the teams come in, present all that data. We're going to sit and talk about it, and then we'll kind of take a break and let those little sub-teams go off and have their meetings and talk, and then we'll come back. I don't know how long of a break I'll take, a half an hour, an hour. We've done this before when we face a time-critical problem. It's easier to let the teams all hear the data together and make a decision together rather than trying to kind of one by one step through the process of one team's okay and recommends the next thing. We all kind of need to hear the whole story together. So tomorrow, you guys might be looking for data coming out during the day, but really it's gonna head right into that MMT where we hear the story and then decide whether we're good to go. Mike can talk to you a little bit about what they're doing at the pad to set up for that. The team's brought some options forward to look at, can we just R&R that circuit breaker? Can we R&R the engine controller? And R&R, I mean remove and replace. The work to do that is pretty invasive, both on the engine and on the controller and on the circuit breakers. We probably could have taken that work, but by doing so, we would have introduced a fair bit of risk into the system by making that change. Anytime you break an electrical connection, we like to do a complete retest of that connector. Some of those circuits we can't retest at the pad. Main landing gear, prox-op sensors you can't go test. ET doors we can't go test right now. So there's some things we couldn't retest, and so we'd have to buy some risk. And really, Mike and I talked right up front, and it was not worth even talking about that risk. So we took that right off the plate. And what we're going to do is focus on the rationale to fly in the condition we're in. And if that rationale tomorrow doesn't sound good enough, we'll see what more time we need to make it a story that we are comfortable with. And ultimately, if we find that we cannot get comfortable with the scenario we have, then we'll go down the path of R&R because that is a little longer-term investment in time and effort, and then the retest that would be needed to do that. And so that was a lot of risk that by taking that off the plate tonight, we let the teams really focus on the problem at hand and not worrying about too many options at once, which is another thing this team is really good at, is building lots and lots of options. But again, the main theme today was to focus and let them narrow down. And like I said, I think they had the answer for me. It's just a better part of value. And to be honest, it lets me have some dinner then later tonight rather than meeting all night long and then having to come right back in at 5 a.m. to help Mike and let him know and get his team ready to tank the vehicle. So this was a pretty easy decision on my point. The problem is pretty simple. It's got a few nuances that we haven't really seen before. We're going to let the team make sure that we're not doing something a little too, like I said, that we're not being too aggressive on our analysis of the problem, and I fully expect tomorrow we'll hear a decent story and be ready to press ahead with a Thursday launch. So I think that's enough for now. I'll let Mike give you his comments.
All right, appreciate it. We'll see from an execution perspective, we are in the T-minus 11-hour hold, and we will remain there for an additional 24 hours. We'll pick up the clock again tomorrow night at 18:30, assuming that we get the go from Mike and the mission management team that we have sufficient flight rationale based on the anomaly we've seen. I'd like to emphasize one point that Mike made. A lot of the decision tonight, in my mind, was based on crew fatigue. If we had pressed on and gotten through all the discussions necessary to get to flight rationale tonight, probably could have gotten there, but it would have taken several hours. And a lot of the people supporting that flight rationale tonight would have also been required on console tomorrow morning for ET load and, of course, for launch itself. And so from a crew perspective, it made sense to take the additional 24 hours also. Let's see, the rest of the countdown then for Thursday. LOX and LH2 loading will begin a little after 6 a.m. on Thursday morning. The crew will board just after noon time. The window opens at 15:24 Eastern, and we would shoot for a preferred launch time of 15:29. The team has executed an extended hold at T-minus 11 hours quite a few times in the past. It's a very easy thing for us to do. The test directors and test conductors are in the firing room right now executing this plan for us. The RSS will remain in place. We won't retract tonight. We'll do that tomorrow night on time, and looking for a launch on Thursday. The weather, we got a little bit of an update from range weather. The percentages haven't changed. It's still 70% no-go for Thursday. Tomorrow will be the transition day with the front coming through. You see some of that, some of the prefrontal cloudiness out there tonight. And then the major concern Thursday is low cloud ceilings and the potential showers within 20 miles of the SLF. So, we are where we are. We're going to take time to understand this problem. We will pick back up with the countdown tomorrow evening and hope for a good on-time launch Thursday morning now. Thanks.
All right, thank you. We'll now take questions. When the microphone comes your way, please state your name, affiliation, and to whom you're addressing your question. We'll start over in the corner with Mark.
Hi, Mark Kirkman, Interspace News for Mike Moses. I'm really surprised to hear you say that you're leading towards flight rationale. Given the sensitivity of those controllers to current transients, how is it you think you're going to be comfortable with not going in there and even if it is dust or contamination, not going in there and actually cleaning those contacts and making sure that dust can't get back in there? And another part of the question is, I'm not clear, was the voltage drop, the multi-phase voltage drop, and the single-phase spike, were those two separate events at two separate times in the day, or you're saying they both happened at the same time and you're trying to trace them to a single-point failure?
Let's see, they were two separate events at two separate times in the day, but we think the cause of that was a common cause, and that was a circuit breaker. A contamination and when I say contamination, that's being way over negative on what's going on. We have hundreds of circuit breakers on the ship, and this is the way they work. They're a pressure sensitive. You push it in, you engage the metal contact. It's very temperature sensitive. It's very pressure sensitive in order to detect a current change and then pop open if it's above the limit it's supposed to be. So the scenario being that we have it's that history of circuit breakers that gives us the confidence that if it is a circuit breaker, the fact that we've engaged a solid contact, the controller has now been powered up I think twice, both nominal power up signatures each time. The circuit breaker's been scrubbed. We're probably up to at least a half a dozen times now. Every single time it re-engages. So once that contamination clears, it's a good breaker, and we have to be honest, quite a bit of data to show that that's the case with these. So it's going to involve a little bit of risk acceptance, but I don't think it's that big of a limb to go out on to accept that risk. One of the things we need to see, and this needs to move from what I know and what elements of the team know to a formal presentation and acceptance by the program of, yep, that is something we understand, and we do know that there is a little bit of unknown there, but we're willing to accept that. We haven't had a chance to do that, which is why, again, we need some more time to make sure that we're not being a little too forward-leaning with that and not just going on, well, we know the circuit breakers act like this, so that has to be the problem. We want to make sure that we're not doing that. So that's kind of our confidence in the breaker. And the piece that we're really going to give them time is to draw that connection between those two separate events, and how do you show that that's one cause that did that. And again, the engineering teams are pretty confident with that, but they need to spend the time to make sure that they can prove that to us.
Marcia.
Associated Press, probably from Mike Moses. You mentioned, is it an automatic, if you had to go in and replace the circuit breaker or controller, is that an automatic rollback then at that point? And you mentioned wanting to look at all the options of what if you're wrong, what if you are wrong and the circuit breaker doesn't work properly, then what happens?
Sure. So on the repair, the teams have been working in parallel to develop repair plans. We haven't had a chance to look at them and scrum them. I'm not sure rollback is on the table at all. To be honest, we haven't really looked that far down. We're kind of piecing this off in the window we have. We know ends on the 7th. So anything that's a longer term kind of thing, like an engine replacement, is a 2-week endeavor, right? So there's no real need to talk about that one right now because we know that doesn't fit. There are ways to be creative with it, but again, I'm not sure it really buys you much if we're looking at our next launch window opening up December 1st around there. So from that standpoint, we haven't gone very far down the if we are or aren't, which is why we're kind of going to focus on what do I have in front of me that I can do in this period, and that is understanding the problem I actually have. And again, it's a lot like the leaks we had both in the hydrazine system and in the gaseous helium and nitrogen systems. We do a lot of work to repair it, but unless you know what you're trying to repair in the first place, you might be causing more problems in the first place. So it's not time to repair something because we haven't yet identified exactly what the problem is to know that that's something that is the problem. We could go spend all this time replacing a circuit breaker only to find that maybe we were wrong and that is not the common cause. So before we go kick off all that effort, let's go spend some time, make sure we understand our risks. As to the what if we're wrong and the consequences, we'll hear some details tomorrow. But fundamentally, on the basic level, the engine needs only one controller to run, and it has a backup controller if it needs it. And Mark can chime in if I get this wrong. So basically, if the circuit breaker then fails or introduces, worst case would be a hard failure. But to be honest, the controllers aren't very tolerant of a big voltage change, and they're not resettable. So once they drop off, they're done. And so that controller would power itself down. And now in this case, you're talking about the redundant controller on engine 3, I believe. Don't quote me on that one because I don't remember exactly. Oh, right here, SSME 3, engine 3. So from that standpoint, that's not a big deal. That's just that one failure, and we have the redundancy. If a second failure came in and took out the primary controller on that engine, so now you'd have both controllers lost, that engine would shut down. But it's a graceful shutdown, a contained, that's the way it's supposed to shut down. And so you'd lose an engine if that happened. Now you go to when does it happen? When does the first failure happen? When does the second failure happen? And then the consequence of losing an engine. That by itself is also not necessarily a bad day. We're going to go understand all that rationale and redundancy. That gives us confidence to fly. But again, fundamentally, we don't often use our redundancy as the reason why we can go ahead and fly. We like to understand that we have a good, clean system before we start. But the other piece of this that's going to be good is we have the ability to monitor this right up and through main engine ignition and even SRB ignition to know if the problem does reoccur. If it did reoccur, that would probably give us pause. But again, we need to tie that, and that's one of the forward actions coming out of tonight was if it occurs again, what's that mean? What are you going to do about it? And so the teams are going to build that story for us as well.
Bill.
Bill Hart with CBS for either of you. But just to follow Marcia's question, if it's anything other than develop rationale to fly as is, are we out of here in this current window? In other words, can you replace a circuit breaker or panel and get that done and still get an opportunity at the end of the window, or is it fly as is or nothing in this window?
Well, let's see, the teams are developing that plan to change out the circuit breaker. I can tell you it would require powering down the ship before we would go after that circuit breaker and the panel that it's on. Before you power down the ship, you have to get the cryogenics off for the fuel cells, so we'd have to deservice PRSD. Then power down the ship, get into that work, reload PRSD, get back into launch countdown. It'd be very, very tight, I can tell you. The guys are looking at that plan right now. I don't have the answer for you. I can tell you it'd be very tight, though. It'd be a lot of work, and that's what Mike was getting into earlier. Or is the value of that worth the risk of doing all that work? You're opening up this panel, you're changing out a circuit breaker, not knowing that the circuit breaker is exactly the problem right now. We may be chasing the wrong thing, and so we really want to understand where the problem is before we press on. L4.
So yeah, left-hand side behind the commander. And just to expand, right, so you guys don't go write the articles that say shuttles pressing ahead with schedule pressure because they must fly in this window. That didn't factor at all into my decision. If I'd have had, like Mike said, we talked before the MMT, if I'd have had 2 weeks of launch time, I still would have made this decision tonight because we don't yet understand enough what to do next. And so tonight lets everybody understand it. Tomorrow we see what the action is. If tomorrow we come in and go, we either still don't understand it or we understand it and we need to fix it, then we're going to go do that. We're not going to just go fly as is. But so when I say we're going to go focus on fly as is, that's not to preserve schedule. That's really to understand the problem first. And we kind of talked about this when we were talking about the leaks. Fix the problem and then set the launch date. So we're going to go understand the problem and decide if we have to fix it, and then we'll talk about the launch date.
Irene.
Thanks. Irene Klotz with Reuters. Two, launch window questions. Thursday, would the weather be a factor in whether you decide to press ahead, assuming the flight rationale works out? And did JSC get anywhere with opening up Monday as a launch option?
See, on the opening up Monday, I haven't heard. I haven't talked to them. I know they're working that in the background. Kind of the guideline I gave them was after a couple of scrubs, then they should start turning up the heat. I think we've now passed that criteria, so I suspect tomorrow they'll start turning up the heat and see where that falls. And so I can't answer whether the 8th is good or not. And that's a pretty big, complicated problem. It's not just JSC; it's the Russians and the ISIS program and the partners. So we'll go talk about that at length. But I'm not ready to have that discussion just yet. So I can't answer that one. On the I just drew a blank on your first question, Irene. I'm sorry. Yep. Let's see. Personally, I don't like to do that. I would be very hesitant on more than 24-hour forecast to go make a decision. We've tanked before with 70% no-go. We've tanked with 80, 90% no-go and had a really good day that day. So we'll play that one by ear. I'll probably take that one down to the wire, and we'll go to the tanking meeting and decide if, for the weather that's about to hit us in 12 hours, is it the right thing to do. So no, I'm not going to factor the weather in ahead of time on that one.
Todd.
Todd Halverson in Florida today with two, if I could. The first, I guess, are both for Mike Moses. If this voltage irregularity cropped up during main engine startup after the engine's ignited, would it in and of itself cause an engine shutdown on the pad? Is it within specification? I just don't understand that.
Yeah, the magnitude of the signature we saw would not have caused any problems. It's within tolerance of the system to handle it. We didn't violate any limits. We didn't violate any LCCs, launch commit criteria. We didn't violate any spec on the box. So this is just a due diligence of a signature that is somewhat unexplained and somewhat unexpected, but by itself clearly passes the limit. And had this occurred at a period where we couldn't take action to stop and talk about it, like at main engine start, it would have actually not affected the system at all, and we would have lifted off just fine.
Okay. And I was curious as to what it is you need to hear as the chairman of the MMT to have the confidence to go ahead and press ahead. What do you need to hear in this story?
Well, I kind of laid that out at the beginning. We basically need to talk about an integrated end-to-end understanding of the problem, and that we haven't drawn the dots to say that this two separate signatures is one problem, and that's actually physically explainable. I think there's a fair bit of historical data that guys can bring to the table to help us show that while maybe not noticed before, this is probably not an uncommon signature. We're literally talking about a 40 ohm change in resistance in the circuit. And if you know your electronics, which I don't, that's nothing. I mean, that's hardly anything. And so the fact that we've never really seen it before maybe is not because we weren't looking at this level of detail before. And so we might be able to pull something out of the hat that just says, hey, this actually is very explainable and it's a known condition and we're good. That would obviously give me great confidence to fly. And so the ability to draw that connection, that we do truly actually physically have an explanation for the problem and that it's not just a convenient explanation, is really what I'm personally looking for tomorrow.
In the back, please.
Mark Ratterman from Talking Space for Mike Moses. Is the problem that you're describing and looking at historical data, is that something that's easy, difficult? Is it something you have tools to do, or does it require recall from individuals on the team?
No, and Mike can talk to the process. It's actually very easy to do. In fact, by the time we hit the MMT, I think they had finished reviewing this flow's worth of data every time that circuit breaker's been cycled, and I think they've been in the one or two flows before that. The main engine guys are already 5 or 6 flights back in history looking at their problems. We call it it's a PRACA database, which is a problem reporting and accounting, and I don't remember what the last A is.
Corrective action. Corrective
action, thank you. That database is an easily searchable tool. We're able to put in circuit breaker part numbers, main engine controller part numbers, and it'll flag every instance of a problem that affected those, and they can be screened pretty quickly. The teams have done that. Via that, we've learned that on STS 90, and I forget exactly when in the count, but the problem that we saw initially where we throw the switch and one of the phases doesn't come on happened in that flow, and it wasn't in a condition that was known then. And the failure analysis that went along with that, we're able to look at and build on. And then, and I forget which flight it was too, but the potential of this voltage drop-off has happened before. At that time, it was correlated to an actual brush where they bumped the circuit breaker. That circuit breaker being bumped momentarily made it hiccup, which then induced this scenario. So again, we have a very good physics-based understanding that the circuit breaker can cause these problems, but let's make sure we've got all those ducks in a row. So to answer your question of how hard it is, it's actually pretty easy. The hard part is it's a lot of data, and there's a lot to talk about. And that's kind of what I mean. I think the answers were all there today, but we hadn't yet had a time to pull it together and organize it and make sure it does flow end to end.
Greg.
Hi, Greg Dobbs from HDNet Television. Of the several reasons why launch windows sometimes come to an end, what's the reason this time? Why is Sunday the last day until December?
Let's see, this one is a beta cutout, so that's the solar angle that the sun makes on the orbit when we're docked to the space station. The shuttle itself can't do much to control the temperatures. The sun hits the same part every time, and it overheats a few components on the shuttle. If we were undocked, we'd kind of do a barbecue roll to keep the heat evenly spread. But when we're done station, we can't. That limit used to be 60 degrees. I think they've been looking at increasing it to 65. So that's kind of what we're talking about of do we have a little wriggle room to maybe get a couple extra degrees and give us one more launch attempt. But that's really the cutout for this one, is that beta angle.
Okay. Mark, you had a follow-up?
Mark Kirkman, Interspace News again. I'm sorry. In your answer to Todd, I got a little confused in how this first presented itself. Were you not able to power DCUB at all initially, and then it magically powered itself up, and then you cycled the breakers?
Yeah, so we pushed, all three breakers were in, and then the power up is to turn the switch on a single three-phase switch. And so we threw that switch, and when that happened, the controller did not come up. And the data pulls to understand why that happened revealed that phase B did not, no power went out on phase B. So while the teams were doing that data pull to try to understand why phase B didn't come on, you saw phase A and C pick up a little bit of the extra induced load, understand that we don't have a short circuit, anything going on. While the teams were doing that, it took about an hour and 40 minutes. And when they went back to the troubleshooting plan, which would be to cycle breakers, the controller was on. And it wasn't that it magically came on, but basically the theory is that contamination basically, the spring-assisted circuit breaker pushed through that last little bit of oil or carbon, whatever happened to be on the contact, or that the dielectric just became overcome and a connection was made. And so that's the signature we saw. We then, after that, scrubbed that breaker by pulling it out, pushing it back in, pulling it out, pushing it back in 5 times with a mark, measuring the currents, making sure everything looked fine. From that point on, everything looked perfect with that power up. The signatures, the traces, the main engine controllers, diagnostics, everything from there on was fine. So that first initial signature was really just a delayed power up because of a not completely made connection on one of the 3 phases.
Irene.
Thanks. Just out of curiosity, under that scenario, if this transient should happen again, would that fit with this flight rationale you think is going to be pulled together, or would it sort of knock that out of the...
No, it fit very well. Actually, the historical consequences of these type of problems in circuit breakers are that when you scrub them, you eliminate that problem and it now is a good latched breaker, and that won't happen again. The part that's making us pause and why we didn't just press right ahead and go to fly is that a few hours later we saw that circuit breaker, for lack of a better word, kind of dribble the voltage a little bit. And we don't know exactly why that happened because we haven't ever noticed it before. It might be because we weren't looking before. It might be because we don't quite understand the failure mode, and that's what we need to find out. So the concept of if this was just that breaker, we scrubbed it and it made a good contact, the teams were ready to go, we're good with that problem. We've cleared that and it's okay to fly. That happens a fair bit on these breakers.
And if you saw that dribble thing again, would that be an issue?
Yeah, so as some of the other questions said, if this reoccurred as is, it doesn't violate any limits, it doesn't hurt the controller would have been just fine. So if it reoccurred at the magnitude we saw it, there'd be no problem whatsoever. We just want to make sure we're not, that if it gets worse, what's going to happen? If it happens at the wrong time, what's going to happen? Is there a way it can manifest itself differently, affect multiple controllers? We're going to answer all those questions before we're ready to fly and not just go on if it repeats itself, it's going to be okay, so that one's okay. We need to know why it happened and what happens if it gets worse.
Bill?
I assume the commander listened in to the MMT. Did he have any comments on any of this and where you guys are going?
Let's see. Typically, the crew's not actually part of the MMT. We do have a flight crew rep on the team, and so he was definitely there and involved. Again, today's MMT wasn't a question and answer session. It was more of a lay out the problem, recognizing that we're not ready to present, and giving the teams the action to go back and gather that data. But they have been following all day long and plan on following overnight. So, as far as Commander Lindsay and what his personal level of knowledge is, I don't yet know, but we will be tagging up with him later.
Another one for Mike Leinbach. Obviously, this is the last flow for Discovery. You guys, it's turned into a little bit of a drama, I guess, with the valve issues you guys have had and the troubleshooting. Any disappointment on the team, or is it just another day in the firing room?
It's another day in paradise. I mean, this is part of the business. You fly when you're ready, and you don't if you're not. And we're not ready to go now. Discovery's not going out easy. She's giving us a little bit of trouble, but that's fine. She'll fly perfectly when she does.
And this is the way it lines up, right? Every step of the way through the countdown, and it's built the way it is for just that purpose. You do a lot of checks ahead of time before you get to the pad. When you get to the pad, you check it out. but ultimately it's all leading towards all those parts and all those pieces and all those electronics all come on at the very end. And so as we get closer and closer to launch, we're testing more and more of those systems and revealing sometimes hiccups in those systems. So we still have a long way to go for launch. We got that whole big tanking thing to do.
Are there any further questions? Well, that will conclude our STS-133 status briefing for tonight. Updates to the briefing schedules and countdown will be on our webpage at www.nasa.gov/shuttle as they become available. Thank you.